Hey guys, it's Miss Johnson, and I'm here to bring you our first notes for Unit 3. We're moving into a unit on polynomials, and today our learning target is I can identify the parts of a polynomial. Now this is kind of a unique notes because we're not actually going to do a practice assignment with these notes. We're just going to take some notes, write down some definitions, and then move into notes 2. So you're going to have quite a bit of writing to do today, but again, you're not going to have a practice assignment with it, so this is just kind of everything in one. So we have some definitions to write down. Now I'm going to talk about those definitions, and then you can pause the video as you need to write them down as we go. The first one is a term. What is a term? A term is a number, variable, or the product of a number and or variables. Other things to know about terms is that terms are separated by addition and subtraction. Okay. So for example, a term might look like, 4x squared. That's one term. Another term might just look like 7. Could just be a number. Another term might just look like y. Could just be a variable. And those terms are going to be separated by addition or subtraction. Now remember, you can pause these videos at any time in case you need to take a little bit more time to write down what's being said. The next definitions that we're going to look at, base and exponent. Now we're going to be talking about powers a lot in this unit of polynomials, and the base is the number part in a power that's being multiplied. The exponent is the number in a power that tells you how many times to multiply the base. So for example, if you were looking at something like 2 to the third, 2 is the base and 3 is the exponent. And what this is saying is you need to multiply 2 3 times, by itself 3 times. So 2 times 2 times 2. Okay, a lot of people look at this and think that it's 2 times 3. It's not. It's 2 to the third power, which is 2 times 2 times 2, which is actually 8. Next one, coefficient. The coefficient, now you've heard me say this word a lot, but the coefficient is the number part of a variable term. So for example, if I look at something like 4x, 4 is the coefficient. Now, degree, this is a new word for you. You probably have not heard the word degree before. The degree of the term is the exponent of the variable in the term. So if I'm looking at something like 6x to the third, this has a degree of 3. If I look at 4x, this has a degree of 1. If I look at the number 7 by itself, this actually has a degree of 0 because there is no variable part. This would be the same as saying 7 times x to the 0 power. So its degree is 0. This is the same as saying 4 times x to the first power. So its degree is 1. So the degree of a term is just the exponent, the value of the exponent. Like terms, we all know what like terms are, but let's just refresh our memory here. Like terms are terms that have the same variables raised to the same powers. Another thing to note is that all constants are actually like terms. And then that brings us into constant. Constant is a term that contains only a number. They have no variable part. Okay, so for like terms, if we talk about like terms for a second, like terms would be saying something like 3x plus 4x. Those are like terms. However, 3x plus 4y are not like terms. And also 3x plus 4x squared, those are not like terms. 3x and 4x are like terms because they have the same variable raised to the same power. This has different variables. This has the same variable raised to 2 different powers. Constant is just a number. That's all a constant is, 5, 100, -2. Those are all constants. They have no variable part. Next one, polynomial. This is what our whole unit is based on. Polynomial is a set of terms that are separated by addition and subtraction. Separated by addition and subtraction. degree of a polynomial, we already talked about what the degree of a term is, but the degree of a polynomial is simply the largest exponent of all the terms in the polynomial. And standard polynomial form, polynomial is written in standard form when all the like terms are combined and terms are written in descending order with the largest exponent first. So we start with the biggest exponent and move down from there. So if we had like an x to the third, it would go x to the third, then x to the second, then x to the first, then constant. So start with the largest exponent and move down from there. Again, don't be afraid to pause the video if you need some time to write down your definitions. The last definition that we're looking at, leading coefficient. The leading coefficient is just the coefficient of the first term as long as the polynomial is in standard form. So the polynomial must be written in standard form first, and then the leading coefficient is the one in front. So now let's get to some practice examples here. We're going to look at the practice examples on the back of your notes page. So taking a look at number 1, it says, given the polynomial 4x to the third plus 8 minus 3x plus 8x squared minus 12 plus 5x plus 3x to the third minus 5x squared. Holy cow, lots of terms in this polynomial. Now, we want to write it in standard form. What that means is we need to combine all the like terms and put it in order from largest exponent on down. So if I look for the like terms, I have 4x to the third here, and I have 3x to the third here. So those are like terms that can be put together. 4 plus 3 gives me 7x to the third. Now I'm starting with this because x to the third is my largest power. Here I have a constant, there I have x to the first, there x to the second, constant, x to the first, x to the second. So x to the third is my largest power, so I know that's going to come first in my standard form polynomial. Once you've taken care of those, I suggest that you cross them out. Okay? When you've got a long list like this, it's easy to mistake things and look at things twice, and if we cross them out, we know we're done with them. So after x to the third, I need to look for x to the squared. I have one here, and I have one here. This one has a coefficient of 8. This one has a coefficient of -5. So 8 minus 5 gives me 3. That's plus 3x to the second. Done with the squared, done with the squared. Then x terms. I have -3, +5. -3 plus 5 is 2. So plus 2x. That's gone and that's gone. And last but not least, we have the constants. +8 minus 12. 8 minus 12 is -4. So -4 at the end there. Now I've taken care of all of those. That's my standard form polynomial there. How many terms are there? Once the polynomial has been simplified and put into standard form, there are 1, 2, 3, 4 terms. What is the degree of the fourth term? 1, 2, 3, 4. My last term is a constant, so its degree is 0. List all the coefficients. Coefficients are the number parts of the variable terms. So I need to look at 7, 3, and 2. And what is the constant? The constant here is -4. So those are all the parts of the polynomial that we're going to look at. Now I'm going to leave number 2 for you to try on your own, and we're going to skip down to number 3. In number 3, it says write the following polynomial in simplified standard form, then identify the given characteristics. So standard form, again, we want to look for like terms and the largest exponent. I see that the largest exponent is x to the 5th. I have 5x to the 5th here, and I have no other x to the 5th to combine with it, so it's just going to stay by itself, 5x to the 5th. Then I would look for an x to the 4th. That's an x to the 3rd, x constant, x to the 3rd, constant, x to the 1st. I don't have an x to the 4th, so I'm going to skip that term. I'll go down to x to the 3rd. Here's an x to the 3rd, and here's an x to the 3rd. 3 minus 2 gives me 1, so that's plus 1x to the 3rd, which we don't need to write the 1 as a coefficient. We just write it x to the 3rd. So I'm done with that, done with that. Then I would look for x squared. Here I have an x, constant, constant x, no x squared, so I'm going to skip that one. So then I go down to the x, that's a -2, that's a -4. Putting those together is -6x. Notice, by the way, that when I combine my like terms, my power doesn't change, just the coefficient out front. And last but not least, I'm going to leave or put the constants together. I have 4 and 5, which gives me 9. So I'm done with that, done with that. That's my standard form. Now, the degree of the polynomial is simply the largest power. The largest power that I see is 5. So my degree of the polynomial there is going to be 5, and again, that's the largest power or largest exponent. And the leading coefficient in this case also happens to be 5, but it's a different 5. It's a 5 that's the coefficient in front. As long as it's in standard form, then that rings true. As long as it's in standard form, then it's the coefficient that's in front. All right, I'm also going to leave number 4 for you to do on your own. So I want you to practice number 2 and number 4 on your own, and then I want you to hop back to Schoology and um, fill out the little Schoology quiz. Thanks for listening. Have a great night, and I will see y'all tomorrow.